All right, let's talk about the invisible force that, well, literally holds our world together. And no, I'm not talking about some abstract concept. I'm talking about the actual stuff we use to build everything around us. Building materials.
Seriously, have you ever just stopped and wondered what holds it all together? The screen you're looking at right now, the chair you're sitting in, the building you're in, it's all made of something. These materials are kind of like the unsung heroes of our world, and getting to know them, well, that's like getting the secret blueprint to how we've built, well, everything. So here's the game plan. We're going to start with what these materials even are. Then we'll look at where we get them, dive into their secret powers, see what happens when we put them under pressure, and wrap it all up by looking to the future. Sound good? Let's go.
Okay, first up, the world we build. And we're going to start at square one. I mean, what are we even talking about when we say building materials?
You know, the definition is almost ridiculously simple. It's any material used for construction. That's it. But think about what that covers. It's everything from, a mud hut made thousands of years ago to a high-tech space station orbiting Earth. It's the ground floor for all of architecture and engineering. And what's so cool is that you can literally read the story of humanity just by looking at the materials we've used. Our entire history, our progress. It's all wrapped up in our journey of finding, shaping, and getting creative with these blocks. They're not just building houses, they're building our civilization's story. Okay, so where does all this amazing stuff come from? Well, you can pretty much sort them into two big buckets. And that leads us right into our next part, nature versus invention. In one corner, you've got your natural materials. This is the stuff we basically just grab from the planet and tidy up a bit. Think stone, timber, clay. And in the other corner, you have man-made materials. These are the ones we cook up in labs and factories, things like steel, concrete, plastics, all designed to do a very specific job. And right there, you've got this fascinating trade-off, right? Natural stuff is usually easy to find and doesn't take a ton of energy to get ready, but man-made materials, oh, they give us one huge advantage: control. We can engineer them to be perfectly consistent, ridiculously strong, super flexible. Basically, we can custom design them for whatever we need. So that's the big question for an engineer, isn't it? Do I use wood for this or steel? And the answer always comes down to one thing: understanding the material's properties. This is where the science gets super, super practical. Think of every material as having its own unique personality profile, defined by its properties. We can break them down into three big groups. Physical properties, that's stuff like how heavy it is or its color. Chemical properties, like will it rust? And then there's the big one, the one that's absolutely crucial for construction: mechanical properties. So what are mechanical properties? In simple terms, it's all about how a material reacts when you mess with it, when you push it, pull it, or twist it. Is it going to bend? Is it going to snap? Getting those answers right is, well, it's literally the reason buildings don't fall down. Let's zoom in on two really important ones. First up is elasticity. You know how you stretch a rubber band and it snaps right back to its original shape? Bam, that's elasticity. The material changes shape under force, but it has a memory and wants to go back. This is so important for things that need a little give, like a bridge swaying in the wind. And on the flip side, you have plasticity. Think about a paper clip. You bend it, and it just stays bent, right? It doesn't snap back. That's plastic deformation. And hey, that's not necessarily a bad thing. It's actually the property that lets us shape metal into all the useful things we need, like steel beams or parts for a car. So, knowing the difference between elasticity and plasticity, that's the key to understanding this constant battle that every single structure is fighting against forces. So let's get into that dynamic. Okay, so it all begins with something called a load. A load is basically any outside force that's trying to push a structure around. It could be the weight of all the people inside a building, a huge gust of wind, or even the violent shaking of an earthquake. And that load kicks off this little chain reaction. It's a three-part story. First, the load shows up and applies force. Second, the material itself fights back. It develops this internal resistance, which we call stress. And finally, if that stress gets to be too much, the material starts to change shape, to deform. We call that strain. Honestly, the entire field of structural engineering is just about managing that delicate dance between load, stress, and strain. All right, so we've talked about what they are, where they come from, and how they work. But let's bring it all together now. The big question: why does any of this really matter?
It really boils down to something simple but incredibly powerful. Knowing if that beam needs to flex or stay rigid, if that foundation can take the weight, if that wall can handle the stress. Look, these aren't just questions for a textbook. These are questions about safety, about lives. Getting this stuff right, that's the line between a building that stands for a century and one that ends in disaster.
And that leaves us with one last big thought to chew on. For thousands of years, our story was written in stone and wood. For the past 100 years or so, it's been all about steel and concrete. But now, we're facing brand new challenges, right? From a changing climate right here on Earth to dreaming about building cities on other planets. So the question becomes really urgent. What comes next? What are the materials that are going to build your future? It's something to think about. Thanks for joining me.